Okay, so now we're going to move on to polar coordinates and polar equations. We were doing parametric, now we're on polar. What's that all about? I know, right? Well, we're going to learn that, right? But again, this is the third video, or third section. We only have one more section, then we're done for the year. So brought in another friend. You might have heard this speech before. This is my friend Marshall. But again, it's just trying to inspire, maybe motivate you a little bit.
Look, if you had one shot, one opportunity, seize everything you ever wanted, one moment, did you capture it? Just let it slip.
So again, just something to think about. But polar coordinates. So what are polar coordinates? So that's what we're trying to find or understand in this video here is what are polar coordinates? How do we plot them? How do we rewrite them? And we need to understand a little bit of vocabulary first. So first is pole. Well, I know what a pole is if I run into one, but in terms of polar coordinates, the pole is a fixed point. Basically, think of the origin as the pole. It can be any fixed point, but we will see it as the origin. The polar axis is an initial ray from the pole. It's going to be the x-axis. The polar coordinates are always written in the form r comma theta, where r is giving us a distance and a direction, and theta is giving us a direction from the polar axis. So we can see that a little bit more here in this diagram. So we have our polar coordinates r theta. Here's the pole, here's the polar axis. So theta is what I normally think of with theta. Think about, our angles on the unit circle, trig, all that fun stuff. R is a directed distance. So here's one thing that you really have to be careful with in understanding polar coordinates. R can be positive or negative. All right, most of the time we think of a distance as positive, and yes, a distance is positive, but because it's a directed distance, negative is implying direction. It's not implying the distance part of it. So r is a directed distance, positive or negative, of the point from the pole, and theta is the angle from the polar axis to OP. Let's look at an example. Okay, so we want to plot the point and find 3 additional polar representations of 2 comma 3 pi fourths. And we only want to use, or we only want to look between negative 2 pi and 2 pi. Otherwise, technically, we know that there are an infinite amount of ways in which we could write this coordinate because of the idea of coterminal angles. So if r is 2, I'm just going to draw, I'm just kind of freehanding that. So I'm going to say that that's 1, and then this is 2. So in terms of what I'm saying is from the pole, I'm saying that this first circle is a circle with radius 1, the second circle is a circle of radius 2. So where is the point 2 comma 3 pi fourths? Well, 2 comma 3 pi fourths is going to be somewhere right here. So that's my point 2 comma 3 pi fourths. This is how I would plot it. Hopefully relatively straightforward. Now the next question though is how can I rewrite this point in different representations? Well, and again, I want to be between negative 2 pi and 2 pi. Hopefully we can understand in terms of coterminal angles, right, which we are familiar with, that 2 comma negative 5 pi fourths would also be a representation of this. Because 2 3 pi fourths is going this way, 2 negative 5 pi fourths is going this way, but it's still between negative 2 pi and 2 pi. Now the next 2 representations that I'm going to show you, this is where we need to understand the idea of a directed distance. So in terms of plotting this point, let me try to explain this a little bit more detail. So in terms of plotting the point 2 3 pi fourths, the way I want to think about that is first think about, okay, what is the ray of the angle 3 pi fourths? And that is along this line here, right, from the origin going up this way. So now then the 2 is what I'm going to do second. What I mean by that is in terms of plotting these, find the angle first and then go this distance out in the direction of the angle. So I would go out positive 2. Well, I can also represent this with a negative 2 by doing negative 2 comma 7 pi fourths. So think about how that works. Well, where is 7 pi fourths? Well, 7 pi fourths is over here. So this is 7 pi fourths, but if I was to draw a line through the origin, it would be the same line that would also go through 3 pi fourths. So if I picture going, kind of looking in the direction of 7 pi fourths, but then going backwards. So that's what the negative is telling me. It's telling me to go the other direction from what would be the positive direction of going towards 7 pi fourths. So then the third way I can represent this would be negative 2 comma negative pi fourths. So again, negative pi fourths is just right here, same thing as 7 pi fourths, those are coterminal angles, but negative 2 is telling me to go the other side of the origin from this angle. But the distance is 2, but the negative tells me to go the other side of the origin. So that's how we can rewrite polar coordinates in many different ways. I want you to practice. So next, try this on your own. Plot the point and find 3 additional polar representations between negative 2 pi and 2 pi of 5 root 2, comma, negative 11 pi 6. Pause the video, unpause when you're ready to check. All right, so here I know that negative 11 pi 6 is like right here, and 5 root 2, I'm just gonna estimate that. I mean, these graphs are not going to be perfect. In fact, plotting polar can be a little bit tedious at times. So it's more of an understanding. So I'm going to say that this is the point 5 root 2 at the angle of negative 11 pi 6. More importantly, how else could I represent this? Well, I could rewrite it as 5 root 2 comma pi 6. That is going to be the same as negative 5 root 2 comma 7 pi 6. And it's also going to be the same as negative 5 root 2 comma negative 5 pi 6. Because think about, well, where are 7 pi 6 and negative 5 pi 6? They are on the opposite side of the origin from negative 11 pi 6 and positive pi 6. Last one, try this. Plot the point, find 3 additional polar representations. Pause the video, unpause when you're ready to check. Okay, so here, this is a little bit of a, I don't know, maybe you would call it a trick question. It's not intended to be a trick question, but basically there's an infinite amount of representations for this location, because if r is 0, then we can really use any angle, because then what we're actually plotting is the pole. So this point is one of an infinite amount of representations of the pole. So other ways we can write this would be 0, comma, pick your favorite angle between negative 2 pi and 2 pi. All right. I'll take it from your silence that you don't have any questions. Now let's look at conversions.